Hi everybody, welcome to lecture 4 of this module. In this lecture, we will continue our discussion on object-oriented programming using C++. The today's agenda is as follows. We will start with a brief summary of previous lectures. Then we will go ahead and discuss about virtual functions. Today we will discuss in detail about polymorphism and different forms of polymorphism. We will see how the same function can be used with different arguments, types, or numbers in function overloading. Next, we will discuss about operator overloading, where normal operator can be used on user-defined data types. Finally, we will discuss the differences between overloading and overriding. So this is a brief summary of previous lectures. We have studied that objects are instances built from specific classes. We discussed that a derived class inherits the properties of base class in inheritance. Derived class has access to all data members and functions in base class. Based on the type of access specifier, the derived class members will be shared with the class inheriting from it. So we have discussed about access specifiers in detail, private and public, and when we came to inheritance, we discussed about protected access specifier. So when the access specifier is protected, any class which is inheriting from the derived class will have access to the protected members, but any external class would not have. So thus, it protects the data members and functions from external copy. We also saw the same method can be overridden during inheritance, which means that the same function which is called from the base class and derived class will show the modified implementation in derived class. And we had discussed about the different types and levels of inheritance. So today we will start our discussion with virtual functions. In inheritance, the derived class gets access to the protected member data through public access functions. We know that already. The objects in the base class may also use member functions belonging to the child class based on user's choice. To do this, we define a virtual function, that is a virtual keyword is there in the base class and it is overridden in the derived class. So this is we discussed about virtual function introduction. Now we will see an example. So we have placed the keyword virtual in front of the declarator for the show function in the base class. So if you see here, we have kept a virtual keyword. The base classes and derived classes all have functions with the same name. Here also we are using void show. Here also we are using void show function. Then the derived class is derived from the class base. So this is the derived class which we saw. It is derived from public base. All have the member function show. In main, this is the main function. We create objects of class derived. So the derived class, we created an object derived obj and a pointer to class base, and a pointer is created to base class. Then we put the address of the derived class object in the base class pointer in the line. This pointer is equal to ampersand object. So here we have kept the address of the derived class object in the base class pointer. Now the question is, when we execute the line pointer show, what function is called, whether from derived class or from base class? The derived function will be called C. Why? Because this is virtual function. Here late binding happens. Late binding means reference to the pointer is resolved at runtime. So the derived function is called because of virtual keyword. Now we have another function, that is next show, which is also there in both the derived class and the base class. So when that is called, it will call the base class because early binding happens. Here early binding means the reference is resolved at compile time. So like this, we can use the virtual keyword and then call the pointer from the base class or the derived class as required. It's a common practice to declare the method as virtual in the base class, which might be redefined in a derived class. So completely different functions are executed by the same function call. The same function call executes different functions, one time derived, one time base, based on which is the keyword. This is called polymorphism, which means different forms. The functions which have the same appearance but actually different functions are getting called. Polymorphism is one of the key features of object-oriented programming after classes and inheritance. Once the function is declared virtual in the base class, the derived class redefines the virtual function to suit its own needs. Now we will discuss about abstract classes and pure virtual functions. In C++ programming, sometimes inheritance is used for the better utilization of data and you do not need to create an object of base class. For example, if you want to calculate area of different objects like circle and square, and then you can inherit these classes from a simple class shape. So we are making a class shape and inheriting circle and square from there because it helps to visualize the problem, but you do not need to create any object of shape. So when we create a class shape but we want to create an area of circle or square, we need not create any object of shape. We can declare shape as an abstract class. That is an abstract class. If you want to create object of an abstract class, compiler will show error. Then abstract class is a class containing at least one pure virtual function. So what is a pure virtual function? A pure virtual function is that virtual function where expression is equal to 0 is added. So whenever that expression, that function is equal to 0 is added to a virtual function, it becomes a pure virtual function. Adding equals to 0 to virtual function doesn't assign value. It simply indicates that the virtual function is a pure function. If a base class contains at least one virtual function, then the class is known as abstract class. So the syntax for creating pure virtual function is virtual, keyword is added, then return type and the function name with arguments will be equal to 0. Let's see one example. Here base class is abstract class where virtual void show is equal to 0, which means pure virtual function show is there. So it is an abstract class. So we should not create any object of base class. Also, the pure virtual function must be defined outside the class definition. So this function will be defined outside the class definition. If you define it inside it, compiler will give error. Inline pure virtual function is illegal. So in this example, in the main, when we write this statement base obj, it will give compile time error because we cannot create an object of base class. Then when we define the function show inside the abstract class, it will give error because it has to be defined outside as it is an abstract class and pure virtual function. So this is how abstract class is used. So using this, you will understand what is polymorphism. Polymorphism in C++ describes the ability of different objects to be accessed by a common interface. The ability of different objects to be accessed by a common interface. So an object is polymorphic if it is related to one or more other objects. If it is related to one or more other objects that can all be utilized using the same method. So it is related to one or more objects which can all be utilized using the same methods. For example, consider in a room a mouse, a cat and a dog are standing. So from the far corner of the room, a speaker emits a sudden sound. Consider balloon popping. So the mouse, the cat and the dog all immediately turn towards the direction of the sound. The dog will bark, the cat will set twitch its tail, and the mouse sniffs the air. So the mouse, the cat, and the dog are three unique objects. They are not the same. They have certain characteristics which are same. They descend from a generic superclass, say mammal. So the sound of the balloon popping causes each object to process the sound in its own way. Suppose the dog is barking, so it barks. The cat twitches its tail, so it is tail twitching. Whereas the mouse will just sniff the air, that is sniffing. So these three unique objects, they are from the same descendant, but they react differently to the situation. But these objects are polymorphic because although they all behave in a different way, the same method can be used to interact with them. And that method is derived from a superclass. So, same function behaves differently on different set of values, which is derived from a superclass. So, C++ allows you to have two functions with the same identifier, where either the number of arguments or the type of arguments passed to the functions are different. These type of functions having similar name are called overloaded functions, and this procedure is called function overloading. So the function will have the same identifier, but the number of arguments or the type of arguments will be different. This function overloading is a concept where you define many functions with the same name but different input arguments or different types of arguments. During the function call, based on the type and the number of arguments, compiler will select the correct function and call it. If you see an example, here all the functions are overloaded functions because function print is called with integer argument at first, then function print is called with character argument, and finally the same function is called using floating point argument. Although the return type of all these functions is same, that is void, it's not mandatory to have same return type for all overloaded functions. So if we make the following function calls, what will happen? When first function is called, the answer will be calling function 1. Second function is called when we print char a. Then If we print 1.2, the third function is called. So even though the name is same, based on the type of argument, that particular function can be called. This is function overloading in C++. So function overloading is a classification of static polymorphism. Static polymorphism in which the function call is resolved at compile time. During compilation, the function call is resolved using the best match technique. Next, we will see about operator overloading. Operator overloading refers to giving the normal C++ operators such as plus, minus, star and additional meanings when they are applied to user-defined data types. So these normal operators are given additional meanings. Like normally we have A is equal to B plus C, which works only with basic types, integer, floating or char. Now we are attempting to apply it when A, B and C are objects of user-defined class. When we attempt to do that, normally the compiler will give error. But using overloading, we can make the statement legal even when A, B and C are user-defined data types. So we can use polymorphism, operator overloading by giving the normal C++ operators additional meanings when they are applied to user-defined data types. Let's see example. So operator overloading means giving additional meaning to the normal operators when they are applied to user-defined data types. The question is, how will the compiler recognize the difference between a normal plus and a user-defined plus? The compiler identifies that it is an overloaded operator by looking at the data type of the operand. If it is a user-defined data type, then the compiler will know that it is an overloaded operator. If it is a built-in data type, then compiler will do the normal operation. So based on the operands, it will recognize that which type of operator it is, a normal or a user-defined. Now we'll see the example. So in this program, the distance consists of two data items, kilometers and meters, private kilometers and meters. So when we write a constructor with no arguments, the values are initialized to 0. That is the integer value 0 because they are both int. Integer value 0 for kilometers and 0 for meters. But when we write a constructor with arguments where the member data, kilometers and meters are set to the values which are passed as arguments to the constructor. So these values will be passed as arguments to the constructor. Based on that, these values will be initialized. Then there itself, if the meters become greater than 1000, we decrease the meters by 1000 and increase the kilometers by 1. Now, to make the operator overloaded, how do we proceed? In class distance, the declarator for the operator plus function looks like this. So distance operator plus in bracket again distance d const. So the function has a return type of distance and takes one argument of type distance. One argument is d here. So in the operator plus braces function, the left operand is accessed directly. The left operator is accessed directly since that is the object of which the operator is a member. So when we define an object of which it is a member, the operator first operand is accessed directly, whereas the right operand is accessed as the function arguments as d dot kilometers and d dot meters. So it is accessed as function arguments. Then to calculate the return value of operator plus and braces, we first add the kilometers and meters from the two operands. We will add them separately and then we will adjust for a carry also if necessary, which is done in the distance constructor. The resulting values, the kilometers and meters, are then used to initialize a nameless distance object which is returned in the statement. So this distance object will be returned after doing the calculation. So if you see the main distance d1, distance d2, two values are defined for kilometers and meters, then they are summed up. The distance d3 is equal to d1 plus d2 in main assigns the value of the nameless distance object to d3. So the nameless distance object is assigned here. Then when we write d3 dot print, we will get the output from the program, which will be like this. So we get the sum of both the kilometers and meters values. Similarly, functions could be created to overload other operators in the distance class. So you could subtract, multiply and divide objects of this class in natural looking ways. So here we are adding two objects d1 and d2 and not int or float. These are user defined data types. So this is how operator overloading will help. Now some more key points in operator overloading. The number of operands to a function is fixed. For example, a binary operator takes two operands, a unary operator takes only one operand, and this cannot be changed. The same is true for precedence operators. For example, multiplication will be called before addition. Then the syntax is same as the original operator, that is overloaded. So plus can be used only in the format d1 plus d2. Plus plus can be used only in the format d plus plus. Similarly in this program we can get, so if you see this program, we are defining three objects d1, d2, d3. So is this valid? If we write d4 is equal to d1 plus d2 plus d3, yes, it is valid. We can get d4 is equal to d1 plus d2 plus d3. We will use the plus operator just like normal data types. So even though you have user defined distance objects here, you can use it normally. Next, unary operators. We know that unary operators act only on one operand. Some examples of unary operators are increment operators, decrement operators, plus plus, minus minus, etc. So to make both versions of the increment operator, that is prefix and postfix work, we define two overloaded plus plus operators. So there are two different declarators for overloading the plus plus operator, the pre-increment and the post-increment. For prefix notation, it is operator plus plus and braces. For postfix notation, it is operator plus plus and in brackets int. So the only difference is the int in parenthesis. In both these operators, the only difference is int in parenthesis. So this int is not really an argument and it does not mean integer. It is simply a signal to the compiler to create the postfix version of the operator. The designers of C++ are fond of recycling the operators and keywords to play multiple roles, and int is the one they chose to indicate postfix. Of course, the same approach will be used with the decrement operator. So even though we are using in brackets int, it doesn't mean that it is used to initialize anything. It's not an argument. It's a notation. It is confusing, but they have used int here. Now, these are the operators that can be overloaded in C++. Can operate, we can overload plus, minus, star, division, module, raised to the power, ampersand, all these things can be overloaded. But even though so many operators are allowed, there are some restrictions. Overloaded operators don't necessarily have to be member functions. So we will see the restrictions of operator overloading now. First restriction is the C++ operators, most of them can be overloaded, but there are some of the operators which cannot be overloaded. We will discuss about them in the next slide. Then overloaded operators don't necessarily have to be the member functions. At least one of the operands has to be a user defined data type. At least one of the operand has to be user defined data type. If both of the operands are suppose int or float or char, then what is the point in operator overloading? So this prevents you from overloading operators of the standard types. Thus you cannot redefine the minus operator so that it yields the sum of two double values instead of their difference. Next, you can't use an operator in a manner that violates the syntax rules for the original operator. For example, you can't overload the modulus operator so that it can be used with a single operand. Then you cannot create new operator symbols. For example, you cannot define star star function to denote exponential. You can't overload some operators. This is the list of operators which cannot be overloaded. For example, size of, membership, pointer to member, scope resolution operator, conditional operators. These all cannot be overloaded. Next, we will we have studied about overloading now, and previous lecture we studied about overriding. In both the cases, we are defining more than one function with the same name. So, we should see now the most important differences between overriding and overloading. For people who have forgotten about overriding, just a brief review. Overriding occurs when in inheritance the derived class has a different implementation for a function present in base class. So overriding occurs when we discuss about overriding in inheritance. We said that the same function is called in the derived class, but it has a different or modified implementation in the derived class. So there we can use overriding. We override the base class method so that when the function call happens from the derived class, it will be calling the modified implementation. Static methods can be overloaded but can't be overridden. So if you see, it's mentioned here that the static methods can be overloaded but cannot be overridden. Functions which are static, we can overload them. Different type of arguments or different number of arguments we can give, but we cannot modify their implementations. Then the return type. The return type is or can be different for overloaded functions, but it has to be the same for overridden methods. Similarly, the function arguments have to be different in case of function overloading, but it should be the same for overriding. Then we know that overriding is linked to inheritance, as the derived class function will be overridden, whereas overloading is independent of inheritance. Then overloading uses static binding, that is during compile time it is done, whereas overriding uses dynamic binding, that is it is done during runtime. So these are some of the major differences between overriding and overloading. This completes our lecture. So today we discussed about using virtual function keyword in the base class and then overriding it in the derived class. Thus we can redefine the method in a derived class by using virtual functions. Next we saw that polymorphism is a very important feature of object-oriented programming. Polymorphism means many forms. The functions have the same appearance but different actual functions are called. This is function overloading. Then we move to operator overloading, which gives additional meaning to normal operators. So we discussed the different operators, binary and unary, where operator overloading is used. We also saw the restrictions in overloading and which all operators cannot be overloaded. Finally, we concluded our lecture with bringing at the difference between overloading and overriding, which is discussed in inheritance. So, function overloading and operator overloading are an important part of polymorphism, and overriding is an important part in inheritance. Thank you.